Hello friends, welcome to engineering tutorial. So today we are going to resume our discussion on digital electronics, and so far we have discussed various concepts related to Boolean algebra uh, with different types of Carnot maps, simplification of Boolean expressions, and the Quine-McCluskey method and other logic gates, all that. So now we will be discussing about combinational logic circuits, and starting the combinational logic circuit discussion, it will be the basic arithmetic circuits, okay, such as addition, subtraction, multiplication, division, how we can do that using digital circuits. So for that we will be reviewing some basic concepts related to representation of signed binary numbers. I've discussed that, but just to for a quick review, we will discuss that. Okay. So today's topic is signed binary numbers. Now we know the digital systems, it must also be able to handle positive and negative numbers, and there are three main ways in which the integers which are used, they can be represented in binary format. So the first way is the sign magnitude. Sign magnitude form. Okay, this is the first method. The second method is the 1s complement method. And the third one, which is the popular one, which is used in most digital circuits, which is the 2s complement method. Okay, these three, out of which this 2s complement method is very popular, and it is most commonly used in all the digital circuits that you will see. But for the if you want to understand 2s complement method, you need to be very thorough about sign magnitude and 1s complement. Okay, so we'll be discussing them. So we'll start with a very basic one. Okay, so here we have to express -1 in sign magnitude, 1s complement and 2s complement form. So for that, first we have to represent +1. We are using 8-bit format, so +1 is simply, so the usual process is to assign weights. Always follow this process, it will be easy. 6, 5, 4, 3, 2, 1 to the power 0. So it is 1. So here we'll have a 1 bit at this position, 2 to the power 0, the LSB position, and the remaining all bits, it will be 0. So all zeros with 1 in the LSB. Now in sign magnitude, this MSB bit, it is called as the sign bit. Okay, if this MSB bit is 0, it is a positive number. Okay, MSB is called as the sign bit. If it is 0, it is a positive number. If it is 1, then it is a negative number. This is called as the sign bit, the MSB bit, and the remaining bits are called as magnitude bits. Okay, which are used to represent the magnitude. So here, if we want to represent -1, it will be MSB will be 1, and the magnitude bits, they will stay as they are. Okay, this 1 0 0 0 0 0 0 1. Okay, so here the sign bit is 1, so it is negative. Okay, the MSB, and the magnitude bits, they are the same. Okay, in both the cases the magnitude bits, they are the same, only the MSB or the sign bit, it changed, it reversed. Here it was 0 for positive number, here it was 1 for negative number, for -1, and the magnitude bits, it remained the same. This is sign magnitude form. Then the 1s complement form. So in 1s complement form, the positive numbers, they are represented in the same way as in sign magnitude. So it will be in using 8-bit format 0 0 0 0 0 0 0 1. Okay, same way, same as in sign magnitude. Same as in sign magnitude form. Okay, now -1 is simply the 1s complement of this binary representation. 1s complement means if there is a 0, change it to 1. If there is a 1, change it to 0. Just this much. So here the zeros will be changed to ones. 1 1 1 1 1 1. At last LSB it is 1, so we'll change it to 0. Okay, it's not responding. Okay, yes, we'll change it to 0. This is the 1s complement representation of -1, this one. Okay, zeros are changed to ones, 1 is changed to 0. Then the 2s complement form. The 2s complement is calculated by adding a 1 bit to the LSB of the 1s complement. Okay, this. So here for -1 we calculated the 1s complement, which is 1 1 1 1 1 1 1 and 0. Okay, 7 ones, 1 2 3 4 5 6 7 and 1 0. Here if we add a 1 to the LSB position, we will have the result 1 1 1 1 1 1 1 1. Okay, 1 2 3 4 5 6 7 8, all are ones. So this is called as the 2s complement representation of -1. Okay, this, just remember this format. We add 1 to the LSB position or to the 1s complement to get the 2s complement. Okay, so this is the thing.